In this video, we're going to be using equivalent circuits to determine the maximum power we could apply to some load resistance. So we know from the theory, if you read through that in order to get maximum power, we need RL to be equal to RS, where RS is either the resistance of our equivalent circuit, whether that be a Thevenin or a Norton equivalent. So just kind of quickly draw that. So this would be RS for our Thevenin, and for our Norton, this would be RS. And the idea being that what resistor could I put out here that would maximize the power delivered to it if I knew what all of these components were. And so again, that is RL. Because so a very common application of this is like car amplifiers. So you have your amplifier, you don't really control that, but you control your speaker. So you can try to match your speaker with your amplifier to have the right amount of resistance to maximize the power to it. Alright, so to do that, we need to be able to get an equivalent circuit. So we went through and we found, so we previously went through and we found that V Thevenin is 22. So I'll write that down. And we found that I Norton is 2.44. Actually 2.4 repeating. So if you want to see how to do that, you can look up those previous two videos. So to find the resistance RL, I just need to know the resistance RS, in this case, either the Norton or the Thevenin one. And so I can use Ohm's law here, noting that V Thevenin is equal to I Norton times that RS, so the resistance of our source. And to find RS, you just redo this, V Thevenin over I Norton. So I get my 22 divided by my 2.4 repeating. And when you plug that into a calculator, you will get 9. So say you didn't have V Thevenin. Actually, we'll get to that in a second. So that would be the quick way to do this. I've already done that. I now have that. So that is, and to max, that would be RL for max power, assuming I wanted max power. So, and then if I want to find the power that actually goes through this resistor, then all you do is, so if these resistors are balanced, then in this case the current through this will be split in half. I'm going to use the voltage because the voltage is a whole number. Same thing, the voltage will divide evenly since the resistors are equal. Actually, I want to show you both. So power max will be V Thevenin. I want half of it because only half of it is going to go through my load resistor. So this is V squared over R. So we'll get 22 over 2 squared divided by that 9. And you should get 13.4 watts. If you do it with the Norton equivalent, you will get I Norton divided by 2 squared times RS. So again, this is the current's going to go here, and it's going to have the option to split between two resistors that happen to be the same size. So half will go through here, half will go through there. So we'll get 2.4 repeating divided by 2 squared. So we only want half of it, because only half of it goes through the load. And then we will multiply that by that 9 ohms. And again, you should get 13.4 watts after rounding. So that answers the entire question. It's 9 ohms for max power. How do we get the 9 ohms if we already know V Thevenin and I Norton? And then how to find P max. So I'm going to show you what to do if for some reason you don't have V Thevenin and I Norton and you just want to match the resistor, but you don't really care about finding the power in this case. or if you only have VThevenin or just iNorton and not both. So what you could do is we could do a lumped resistance method to find this. So we take our circuit, and what we're going to do is we're going to turn off all of these sources. So this 12 volts will turn into a wire. So the 12 volts is a wire now because it's 0 volts. And I have 6 ohms, and I have 12 ohms, and I have 3 ohms, and this 2 amps will become an open circuit. 0 amps means there's nothing going on there. And then I have my 2 ohms, and then I have A and B. And this is something you did really early on, where you just have a bunch of resistors, and all you need to do is just lump them together. This works because there's no dependent source up here, so everything will clean up and we'll be left with just resistors. So we start off over here. These two are in parallel. So if you go 1 over 6 plus 1 over 12 is equal to 1 over R equivalent, you should find that R equivalent, let me just slide that up for you guys, is 4 in this case. And then if I redraw that circuit, you will have your 4 ohm, your 3 ohm, your 2 ohm, A, and B. And so you can see you have 4, 3, and 2. They are all in series. So 4 plus 3 plus 2 is 9. So you should be left with a 9 ohm resistor, A and B, which is the same thing that we found before. So again, if you only have VThevenin or just iNorton, a quick way, if you don't have dependent sources, is just to do a lump resistance, and all it is just turn off your sources. All right, hopefully that was helpful.